with regards to these, what are called pattern identification sciences, as they're often called, which happen to bear the greatest brunt of the criticisms. Here is where a grave mistake continues to be made, not only by critics of these practices, but also by the forensic scientists themselves that practice these disciplines. And that mistake is thinking that there is, in fact, no larger body of scientific or academic inquiry in which these kinds of analyses are conducted or studied, right? DNA has biology, drug chemistry has chemistry. But what about these pattern comparison methods that we've mentioned here? It's not biology, it's not in chemistry, it's not in physics. So what is it? Is there any overarching scientific body that would or could provide a suitable intellectual or scientific home for these disciplines? And the answer happens to be yes. It is a branch of science, a well-established branch of science and mathematics that's called stochastics. And I've written about this before. I've studied it at length. I've spoken to people who specialize in stochastics. And stochastics happens to often be described colloquially as the science or the study of randomness. Stochastics is a specialized and focused area of scientific and mathematical inquiry that contends with the problems of randomness. But its rise as a field of study later than the rise of forensic science was the problem. So forensic science never really had a chance to make it a home, if you will, in that particular realm of scientific study. But it does exist, and forensic science, in my judgment, would do very well for itself to figure out a way to make its home there. It's not going to happen overnight. But there is no other home for these often heavily criticized forensic disciplines to have, which is why they are so exposed to these criticisms and they have such a difficult time clawing their way out of them. For example, when you look at the wounds on the skin of a victim of a criminal sexual assault, let's say that were left by a perpetrator through the act of biting the skin of the victim. It could be on the victim's shoulder, on the victim's neck, on the victim's breast. So what is left behind on the skin that we can see and what we might describe as a bite mark is actually a pattern of impressions that correspond to the patterns of the surfaces of the teeth that left them there. The way that those teeth grow and arrange themselves in a perpetrator's mouth during infancy and maybe over time, one tooth being angled slightly this way, one tooth being turned slightly this way, one tooth being a bit larger than the ones next to it, all of these things in their totality as a pattern are random phenomena. Now that some or much of that randomness uh, might go away as the result of, let's say, wearing braces. And perhaps you would not be able to identify the perpetrator from a bite mark. But you could potentially if those patterns are pronounced enough and with irregularities and contours that lend themselves to being observed and compared to bite marks that might later be collected directly from the biter under controlled conditions and under the supervision of forensic experts or law enforcement. Now, it is very easy to arbitrarily dismiss bite mark comparisons as junk science, as many critics often do. The skin is too malleable. the patterns are too faint or too blurred to make a conclusive determination. And these very well may be the case. These claims very well may be true in certain instances, but perhaps not in every instance. This means that the endeavor to conduct the comparison of bite mark patterns is entirely legitimate, and it may result in a scientifically justified identification of the biter, or it may rule out a candidate or a perpetrator, or it may be inconclusive. You just can't do anything with it. That's all perfectly acceptable. But the act of making the comparison is entirely legitimate, and to say that it has no scientific value in any conceivable situation is just plain irresponsible. Very irresponsible. I I guess it wouldn't hurt to be a little controversial as we do this. I might be inclined to agree from a semantic standpoint that bite mark comparisons, that firearm bullet comparisons, and latent print comparisons, to name a few, are not in and of themselves areas of true or complete scientific inquiry, and that it might be inappropriate to describe them as sciences. I think you can make a very strong, credible argument for that. Because what they are applications of methodologies that are looking to take advantage of something that is bigger than themselves, and that is stochastic phenomena. And so it is stochastics that is, in fact, the originating scientific home base for these forensic practices. Bullets, the tips of fingers, or the surfaces of teeth, the underside or the outsole of your shoe have stochastic irregularities and contours. And yes, the study of stochastic phenomenon is an entirely legitimate, well-established area of scientific and mathematic and statistical inquiry. This is why forensic science is a different kind of science. It is because forensic science is a historically rare branch of scientific inquiry that predates its academic origins or justifications. It's kind of like a child being born before its parents, in a way of speaking. In reality, stochastics has probably been around back since about the 17th century when probability theory was really coming of age. But actual stochastic analysis in the modern area really didn't establish itself until about midway through the 1900s, and then more recently during the era of computing, because only computers could handle the complexity of these randomness models. For example, in economics, random fluctuations in stock prices are studied to understand investment risk and to predict economic activity or economic volatility. Gaming and gambling are also areas that involve stochastic principles and the study of stochastic fluctuations. They're random. The shuffling of cards is random. Now, there's an interesting matter of again, nomenclature here that I think will be helpful to people that are in forensic science, particularly in these pattern identification disciplines, which I believe we should start calling forensic stochastic patterns, by the way. And those two terms in stochastics that are used are called, well, first, stochastic, which is another way of describing random, and the other is deterministic, which means intentional. And so it's really interesting because in forensic science, because it predates the modern applications of stochastic, we traditionally developed and used different terms. We use the terms class characteristics and individual characteristics, but they mean the same thing. Individual is stochastic, class is deterministic. So I find it really fascinating that even though, and this is a credit, by the way, to our founders in the profession of forensic science, that they were adhering to terminology and methodologies that were in alignment with the field of stochastics, even though they may not have ever heard of the word stochastics or knew what it was, as I did not during my forensic laboratory practitioner years. So the next time you hear that forensic science is junk science or that forensic science is a leading cause of erroneous convictions, all I would suggest is that when we look at the facts, good things happen, as they often do. And what we find when we look at the facts is that forensic science, without question, is a leading preventer of erroneous convictions, and it is to be appreciated and celebrated for what it does to preserve the accuracy and the fairness of our criminal justice system. At the same time, there is a need in forensic science for some of its members to make new and proper connections to their scientific home, which is the study of randomness, which is called stochastics.